Hi, teacher.
Hi, how are you?
Okay.
Where are you now?
Home.
Home. Okay.
Hi, Cha.
Hi, good morning.
Hi, Cha.
Hi, good morning.
Hi, Mahendra.
Anyone
Hi.
know where Bugis and Wingyan is?
No, Cha.
Oh, Cha, I know. They're home.
Yeah. Haha.
I think they're still sleeping.
Why cause hello?
I just messaged in the group. If there's no response, we will start. Okay.
Okay, Cha.
Okay, Cha.
Okay, let's start first, okay? So I have Lohindra, Mehak, Nicholas, Sherlock, and Tachu here. So today we are going to do the last part of chapter 3, and hopefully if we have time, we will do a little bit of chapter 4. Okay, so I am looking at page where? Page 46. I will skip 3.5 because 3.5 is related to the next chapter. So I will teach one shot with the next chapter lah, on momentum, on moment and then momentum. So we look at scalars and vectors first, okay, which is 3.6. Okay, so this is something that you all probably learned last year as well. So it's also like a little bit like a recap lah. Okay, so in science we study many things, and then some of the things we study has a quantity attached to them. Okay, so for example, energy. Energy is measured in joules, but there's no direction. For example, I say, okay, this hair dryer gives an output energy of 20 joules, but there's no direction, it's just an amount. Speed, okay, 20 kilometers an hour, let's say. No direction, just a magnitude. Power, okay, this electrical appliance works in 20 watts. It's just a magnitude. Time as well. So all these things, right, there's no direction. It's just a quantity, it's just magnitude. So this is known as scalar. Scalar means there's no direction, it's just magnitude. So if something in science has quantity, size, or magnitude, but no direction, we say it's a scalar. And please copy down.
Writing.
Okay. So scalar is something that has magnitude, has a size, has a quantity, but there's no direction. So we call that scalar. So write the definition, and then below that you can write examples. So energy, speed, distance, time, power, mass, pressure, volume. So you list down these examples after you write the definition.
Done.
Okay. Who's still copying? Please raise your hand.
Anja.
I'm done.
Done, sir.
So make sure you also put down some of the examples. Okay, so remember again, scalar is something that has quantity but no direction. Okay. Okay, and then there are some quantities that have both the magnitude and direction, and they are called vectors. So for example, mass is a scalar because it's just, okay, 20 kg, 30 kg, but weight is a vector. It has direction. Why? Because weight is related to the pull of gravity. When we look at weight, we're looking at the pull of gravity, and gravity is downwards. It has a direction. So weight is a vector. So please copy this down as well.
Okay.
It's the same with force as well. You pushing force, pulling towards which direction? Towards the right, towards the left. I'm pushing the box towards the right, so it's going to move that way. It's going to move downwards. It's going to move upwards. Air resistance is a force that is, thrust, for example, is a force that's moving forward. Air resistance and friction is in the opposite direction. So all these things have direction. So then it's called a vector.
So, Miss Sharina, anything that like has a direction and a size, it's called a vector. But
It's
anything that does
type of
not
vector
direction.
Yeah.
Okay.
Yeah. Anything that just has a size alone, then it is called, it is a scalar. If it's size and direction, then it's vector.
Okay. Thank you.
Sure, done.
Then let's just give a couple minutes for your other friends.
Done, Cha.
I'm done.
Okay. Okay, who's still copying? Can you raise your hand, please? If not, I'll go on to the next slide.
And
Hi, Miss Grace. Hi, Cha. Cha. Cha.
Don't
Miss
disturb.
Grace.
Don't disturb her lah.
yes.
Hi, Cha.
Good morning. Sorry, I actually thought you were calling for Miss Sharina when you go hi, cha. Morning. Sorry, Sharina.
It's okay, no worries. Okay, so let's continue. Okay, so let's see. Okay, okay, Nicholas. Velocity, is it a scalar or vector?
There is scalar.
Does
Right.
it have magnitude?
No.
No. How do I calculate velocity? What is the formula for velocity? Okay, how do you calculate speed? What's the formula for speed?
Distance over time.
Okay, velocity will be?
Distance over time as well.
Okay, velocity is you put speed in. So velocity, when we want to calculate velocity, it has, see, speed itself, let's say, speed itself is, let's say I traveling at 80 kilometers in 1 hour. That is speed. So that is a scalar quantity because I just have my magnitude. In 1 hour, I'm traveling 20 kilometers or 80 kilometers. So it's just scalar, it's just magnitude. There's no direction. I didn't say 20 kilometers north, for example. Okay, but velocity, when I calculate velocity, it is, what is the formula for velocity?
Speed over time.
So is it the change in speed over time?
Yes, so velocity is slightly different, okay? Velocity is, we are looking at a change in position over the change in time, okay? So velocity is the change in speed over the change in time. Okay, so velocity is actually speed over time. Speed is distance over time. Velocity is the speed, so the change in position in terms of speed over time. Okay, the change in time. So it has a vector quantity to it simply because when there's a change in position, there can be a negative change or a positive change. So that results in velocity having a direction. So it can be a negative, it can be a positive, it can be a negative change in position or a positive change in position. So that is why velocity is a vector quantity. It has a direction. Okay?
Yes.
Okay. Next, Tachu, volume is scalar or vector?
Scalar.
Okay. Beatrice, force is scalar or vector?
Scalar.
Scalar. Why scalar?
So is it vector because force has to be in a direction?
Yes, force is vector. So for example, I take a type of force. Let's say gravity. Gravity is a type of force. Now gravity is always acting downwards, so it has a direction. So it's a vector quantity. Okay. Air resistance, friction. It's a type of force. It's in the opposite direction of thrust, so it has a direction. So it's a vector quantity. Okay. Do you understand, Beatrice? Yep. Okay. Okay, so today we're explaining scalar and vector quantities. The difference, the next part we're going to look at is difference between displacement and distance. Okay? Okay. So far, anyone have any questions?
No.
No.
Okay. Okay, distance and displacement. Okay, so distance, very easy. The length of a path between 2 points. Let's say, okay, from Shirley's house to Nicholas Khoo's house, what is the distance? So you measure. So how would you measure distance? Okay, let's say, Shaluk, you want to go to Nicholas Khoo's house. How are you going to measure the distance? What would you do in order to know how far the house is? Let's say you don't know. Let's say Waze doesn't exist lah. So you don't know what is the actual distance. So you cannot plug it in Waze. So you want to see how far it is. How long will it take you to go to Nicholas Khoo's house? So what will you do?
Teacher,
Yes?
so can it be like you calculate your speed to his house and then how long it takes, so you times, because distance equals to speed times time.
Okay, let's say I don't know what the distance, don't know what the speed is. Let's say I'm walking. Let's say Shaluk decides to walk to Nicholas Khoo's house.
Then he calculates the time he took from his house to Nicholas's house.
What are you gonna? You can't
So,
have
so
this
what time? How is he going to calculate the time?
How number of feet? I don't know. Steps or something.
Stopwatch.
Huh?
Signboard, sir.
Signboard?
signboard.
Signboard. What do you mean by signboard?
Like
Somebody got write like how far, how many meters.
Okay, so how many meters, how many kilometers, okay? Okay, so basically, right, when you want to go somewhere, the most simplest way is, of course, you look at a signboard lah. Let's say you're driving or you're walking. Let's say you're walking. And then to know how far a place is, okay, number one, there are signboards. So they will say, okay, 2 kilometers away, 3 kilometers away, that's one. And then if you want to see how long it will take you, let's say let's say Sherlock decides to walk to Nicholas Khoo's house. So he will time himself. Maybe he start at 9 a.m. Maybe he'll reach at 10 a.m. So it takes about 1 hour. Then roughly he see okay, how far it is. And then if let's say you have a distance tracker on your phone, okay, you put your phone in your pocket, you walk, then your phone will tell you, okay, you have walked 10 kilometers. So you know, okay, the distance from Nicholas Khoo's house to Sherlock's house is 10 kilometers. So distance is basically just the length between 2 points. Okay? And it is measured according to the amount of distance involved. So it's basically just, okay, how many cm, how many mm, how many meters, how many kilometers. Okay, if you're traveling in a car, you want to go to Ipoh, okay, you see the signboard, okay, how many kilometers. So you travel. Okay, now when let's say you're traveling to Ipoh, okay, you're driving. Is it just a straight road besides the highway? Let's say you start from your house. You have to turn to the right and go out of the housing area, go to the main road, traffic light, then go to the highway, and then only you go. Even the highway also is not straight. You have your curves and your turn. But distance is when they put the how many kilometer on the signboard, they take into account all these things, the curves in the highway and stuff like that. So distance just simply means the length of the path between 2 points. Okay, from the start of the highway to Ipoh, okay, this amount of kilometers. Okay, so that is basically that's very straightforward. Like distance is very straightforward. Okay, so distance has no direction. Okay, it's just 20 kilometers, 30 kilometers. So it's scalar. Okay, no direction. So for example, from A to B, the distance is 2.3 kilometers. Okay, drive, okay, 2.3 kilometers. Like for example, if you want to go somewhere, right, and you click on Waze will say, okay, it takes you half an hour. It gives you the exact distance, correct? So it takes into account all your turns, all the traffic light, the sharp bends, the curves and all that. So that's distance. Now, then what is displacement? Displacement is the direction from the starting point where you start and the length of a straight line from the starting point to the ending point. Okay, so distance plus a direction gives you displacement. So when I have a distance and a direction, that gives me displacement. So if we look at this picture, distance is 2.3 kilometers. Displacement is from A to B in a straight line. So logically speaking, will the distance be shorter or the displacement will be shorter?
The displacement
Displacement
is shorter.
shorter.
Displacement shorter because it's straight line. Distance, there's all these bends and curve. So displacement is shorter. Okay, so very quickly, I will turn back. Can you just please take down this one, the definition of distance, and then I'll switch to the next slide and then take down definition of displacement so that you know the difference.
Jordan.
Okay. Who's still copying? Can you
Sure,
raise your
done.
hand? Okay, then I'll change to displacement. Remember, our distance is this, and then displacement. Okay, here you go. The direction from starting point and the length of a straight line from the starting point to the ending point. That is displacement. Please write that down as well. Okay, so we have distance plus a direction will give you a displacement. So please write that down as well. Distance plus direction equals displacement.
Sure.
Okay. Okay, let's move on. So displacement, like you all guessed earlier, displacement will be much smaller than distance. Okay, because distance you take into account the blocks, the barriers, the curves, the turns, whereas displacement is just straight line. That's why you see in the previous slide, the direction from the starting point and the length of a straight line from the starting point to the ending point. Okay. Okay. The key word here is direction from the starting point. So that's why it makes displacement a vector quantity. Okay, so for example, like this. Let's say I'm walking from the school to home. So usually, okay, you go back after school, you go back home, okay, you drive, okay, take all these turns, and then you reach your house. Displacement would be from school right to your house in a straight line. That's displacement, which is much shorter lah, as you can see. Okay. So this is a racetrack. Okay, let's say the race starts there. It's a 400-meter track, but the runner slips and fall here. So half the track lah. So how far did he travel? About 200 meters, because the whole thing is 400. Slip and fell here, so roughly it's about 200 lah, half the track. Okay. What was his displacement? If half the track is 200, displacement will be what?
100.
100. How do I get 100?
Divide 2.
Why divide?
Sure, from there to there, there 200. So shorter can be 100.
Okay, so I mean, you are right that it's lesser than 200, but it's not you simply divide 2 lah. There's a way to calculate it, which you will look at in a while. So it's definitely less than 200. Okay, the exact value we will see how to find later. Okay. Okay, so for example,
My friend.
Your friend is the 5 meter one, the one on the right side.
Yeah, my one.
Okay, come.
Long
Now,
neck.
can you all see the words at the top?
Yes.
Can.
Isn't it the meme, baby?
Yes. Okay, so now, so Billy, who's this boy here, started at A. Okay, so A, he crawled around the whole perimeter of the triangle. So the whole perimeter he crawled. And then he ended up at B again. So he crawl, A to B to C, and then to A, and then back to B. So what is his distance? Distance first. So A to B to C, and then back to B. What was his
18
distance?
now.
Huh?
Yeah, 18.
18.
18.
18.
Correct, 18. Okay. What is his
Yeah.
displacement?
Displacement.
What is the starting point? Starting point is A, and
A.
point is B. So what is the
4
displacement?
meter.
4.
Okay. So the distance is 18. Displacement is 4. Okay. Now let's look at the second one. Jono the giraffe walked around from point A to point C. Okay, what is the distance? If you walk from A and then he go to C. To go to C, it says walk around. That means he go A to D to C or A to B to C lah. What is the distance?
14.
Okay, so 9 plus 5, 14.
Yeah.
Now, what is the displacement? Displacement, so starting point is A. Yeah.
Yeah.
Starting point is A and then he ends at C. So that means the displacement is like this. So this is where your Pythagoras theorem comes in. This is 9, this is 5, because 5 here. So 9 and 5. Now, quickly calculate. I want to see how many of you all can remember Pythagoras theorem. What will A, C, what will the displacement be?
Is it 106?
106? How do you get 106?
I don't know.
What did you do to get 106?
I take the square number, I squared 9
Okay.
and 5, then I plus them together.
Okay, so 9 square is 9 times 9, which is 81. 5 square is 25.
25.
So 81 plus 25 is 106. That's correct. Then
Then square it lah.
I have to square root it. Square root the 106.
10.2.
10.29, 10.3. So the displacement will be 10.3 cm. Okay? Did everyone get that? Anyone confused?
No, cha.
So basically, you have to draw a triangle. This is 9, this is 5. Huh? And then this will be the square root of 9 square
Plus 5 square.
plus 5 square. Pythagoras theorem lah, basically. And then you'll be able to find the distance between here and here. Okay?
Okay.
Okay.
Yeah.
Okay, so that's pretty much it for this section. Okay,
For this
you all can go
section,
and take 2-minute
3
break.
hour,
3 hour
30
break.
minutes
No.
break.
Just go
Yeah,
and
yeah,
take a
yeah.
2-minute break. If you need to stretch,
Okay.
drink some water, and then come back. And we'll continue a bit more.
Okay. ML first. 3.
my hat.
Saya look.
Apa mau?
My hat.
Then Loinda,
Saya mau.
you
Saya
every
mau
time say
limau.
ML, I'll slap
I
you
got
every
say. I
time.
never say.
You all
You
are
listen,
still on
right?
the,
Say one ML, right?
Kaya lah.
you all are still on
Message
the
also
recording,
never see.
and this recording is going to go on Edmodo, and then everyone is going to listen to your conversation, and then yeah. So please beware of what you say. If you want, you all can go and message on WhatsApp. Okay?
You said
Okay.
you wanted to play.
Quiet lah. Later, I only count team you.
Okay, is everyone here?
Yes.
Okay.
Yeah.
Yes.
Okay, can everyone see my screen?
Yes.
Yes.
Okay, so you can see the slide on momentum.
Yes.
Okay. Okay, so let's look at momentum. Okay, now. So we're going to describe and explain momentum as a vector quantity, and we're going to calculate momentum. Okay, those are the two main things we're going to do today. Okay, key points. Momentum is a vector quantity. It has both size and direction, magnitude and direction. So momentum is a measure of how strongly something is moving. Okay, momentum is a measure of how strongly something is moving. Momentum equals to mass times velocity. Okay, so I have the concept of speed inside and I have mass as well. So momentum is mass times velocity. So kg meter per second, that's the unit. Please take this down. You can take the triangle down as well, so that will help you when you are doing calculation. Momentum equals to mass times velocity.
Okay.
So depending on the mass and velocity of something, that will affect how strongly an object is moving, because it can be affected by the mass and the velocity. Okay, who is still copying? Can you raise your hand? Now we'll move on to the next slide. Okay, I'll give you all a few minutes. Okay, keep going. I'll give you all another
Done, sir.
copy. Sherlock done?
Fears a little bit more.
Okay.
They're done.
Okay.
Done.
Done. Okay. This is on page 44 of your textbook, by the way. 44, 45. So I'll just give you a basic introduction to it, and then next week we will move on to it deeper. Okay, Dana, Shaluk.
Yeah.
Okay. Okay, so remember momentum is equals to mass and velocity, and we're looking at a measure of how strongly something is moving, how strongly an object is moving. Okay, so let's try this. Okay. A body has a mass of 2.5 kg. Calculate its momentum when it has a velocity of 3 meters per second. So who wants to try?
So can I try?
Can.
Okay.
So for A, what do you need to do?
2.5 times 3.0.
Okay.
7.5 kg meter per
7.5 kg per. Yeah, okay, never mind.
Okay. So using the formula, oh, sorry, I will have 7.5, correct. Next one, its velocity when it has a momentum of 10. So if I want to calculate velocity based on the triangle, what do I need to do?
10 divided by 2.5.
What am I dividing? Mehak, what am I dividing?
Momentum over mass.
Correct. Oh, I'm taking
4
momentum
velocity.
divide mass. So 10
4.
divide 2.5, which is 4. And
4
what is the unit?
meter per second.
V.
Okay. Okay, I give you all about 7 to 10 minutes. So quickly do number 1 to number 6. Do it by yourself first. And then when you're done, I'll call out. Please write down the question and then do the working as well, so that you know what is you're working on. Okay? Write the questions very quickly and calculate, and then, yeah, and we'll discuss. Okay, Lohendra, you raised your hand.
So that one is now you ask whoever not yet finished copying, ask to raise hand just now.
Oh.
Oh wait, lower my hand. Oops, sorry.
Okay. You can use a calculator to calculate, especially like question 6 and all, you need a calculator. Okay, still doing? Anyone done?
Still doing.
Okay, never mind, keep doing.
So done.
Done.
Okay,
Done.
we'll give a couple more minutes for the others, and then we will be starting. Okay, can I see a show of hands of those who are still doing? If you're still doing, please raise your hand. Okay, then okay, let me ask one by one. Okay, Mehak, what do you get for the first one? What is the momentum of a 10 kg truck traveling at 5 meters per second?
50 kg meters per second.
Yep. So 50 kg meter per second. Very good. Okay, next one, number 2, Tachu. What is the momentum of a football of mass 500 gram traveling at velocity of 10?
5 kg meter per second.
5 kg meter per second. So the 500 gram you must change to kg first. 500 gram is 0.5 kg and then you times 10. Okay. Beatrice, number 3. An athlete running at 8 meter per second, momentum of 520 kilogram meter per second. What is her mass?
Uh, 65.
Okay. 65 kg, that's correct. 520 divide 8. Okay, number 4. What is the momentum of a bullet of mass 50 gram traveling at 300 meter per second? Wing Yan?
15,000.
Sorry?
15,000.
15,000. 15,000. How do you get 15,000?
I use times.
What times what?
50 times 300.
Okay, the 50 you have to change to kg because momentum is kg meter per second. So it's 0.05 times 300, which will give you 15. Okay?
Okay.
Always remember to change it to kg. Okay, next. Shaluk, what is the momentum of a dog, mass 12 kg, fired out of a cannon, oh gosh, at 120 meter per second?
1,440 kg meter per second.
Yep, correct. And the last one, a meteor traveling through space with a mass of 3 times 10 to the power 6 kg, momentum of 6 times 10 to the power of 8 kg meter per second. Calculate the velocity of the meteor. Lohindra?
200 meter per second.
200 meter per second. Okay, anyone has any questions?
Nope.
No.
No? Okay,
No.
then we will end here and we will continue a little bit more on momentum next week and then we will go to chapter 4. Now chapter 4 is continuation, or it's just an expansion of what you did last year when you studied the liver system. So please go through that. If you've forgotten all those, please go through that a little bit. If not, you will be a bit lost in the next class. Okay, so please go and look at liver system and how and moments, calculating moments. Okay.
Okay, sir.
Okay, that is all. Thank you,
Okay,
class.
Right,
Yeah.
class so fast one.
Yeah.
1
So
hour.
class so fast
11
one.
o'clock already. Unless you want me to extend our classes to 2 hours. Is that? Do you all prefer that? Do you all have a class after this?
We actually,
no job.
we actually got nothing after this.
Just nothing.
Okay, I'll ask and see if we can do a 2-hour class. Or
Okay.
at least a
Okay.
1.5 hour class or something like that. I will check and see.
Okay, Chair.
Okay,
Okay,
and
Chair.
I will
Sharina,
put some work on Edmodo. Yes?
Miss Sharina, are you free now?
Yeah.
If you want to, you can continue your class, no problem.
Oh, I can continue, is it?
If you want to, yes. If you are free and you are okay with it, you can continue your class, no problem.
Oh,
It depends on your schedule, actually. I can't remember your schedule.
yeah. Okay. Just, I prepared work. Okay, what I do, class, I will upload all the questions now. So you do the work now and send it to me by before 11. Okay? Since you all have nothing now. So I'll
Before
upload
11.
questions now.
Before 11.
Sir, before
12,
11.
Chair.
12, before 12, sorry. Okay, so you
Okay,
go
you.
Scared that me
work and
before
add
11.
video now like for the next 1
Okay,
hour.
Cha.
Okay? And then next week
Okay,
onwards,
Chair.
I will extend the class.
Good job.
Okay.
Okay, thank you.
Bye
Thank you,
bye.
Miss Grace. Bye
Bye
bye.
bye.